So I've been using this little mini socket set since the mid 2000s. Believe it or not, this thing is over 20 years old, or just about 20 years old. Comes with 27 hardened bits, as well as the ratchet and the extension. Very, very useful tool. I actually use this tool daily when I was in the auto body tech industry. I was an auto body repair guy, but I just did all the mechanical. So I had a lot of tools specific for jobs. These are great for tight spaces. Also for having access to a quick on-the-fly interchangeable bit system. The idea for this video is to try to create some kind of French cleat system that I can mount to the wall and have easy access, and also have an attachment that goes on the bottom where I can use this in a Gridfinity system. That I'll be doing down the road. I'm gonna get some kind of desk setup and or create a longer kind of wall here because I have a laser engraver coming. Keep an eye out for that. That's gonna be the first sponsor to this channel. Very excited. They're sending me out a 3D or a laser engraver. Very new to that as well, but it is some kind of some other ideas I have to incorporate laser engraving with 3D printing. Stay tuned, that's coming soon. If you're tuning back in, thank you so much for checking out the channel again. You guys and gals are awesome. If you're new, my name is Kevin Haggerty. This is my first 3D printer I got in September, and I've been designing and creating stuff for fun, trying to create products that I can bring to the market, so on and so forth. It's a lot of fun. So if you're here for 3D printing, you're in the right space. Let's hop into Fusion 360. First, we're gonna sketch out a couple of things on a piece of paper here. We'll bring it into Fusion, we'll send it to the A1 Mini, and then we'll check it out. Let's go. So the first step to how I've been going about creating sketches from products that I'm looking to, enhance with 3D printing, I'll generally take a measurement of what I'm trying to accomplish, meaning this has a case, it came with a case, and sure, I can just take this case and break it open and have this little holder, but the whole idea is to actually learn more about 3D printing and Fusion. So what I'm gonna do is I'm gonna take a measurement of the bit, I'm gonna take a measurement of the width of the hole here that it fits in, because I would imagine it's spaced just a few millimeters wider for ease of in and out and so forth. So let's get started with that. Let's take a full measurement of this whole thing across. I always like to zero my caliper right before I mess with it because sometimes it gets jostled around. All right, so a rough measurement outside to outside is 97, bear with me, there we go, 97.27. Hopefully that was in focus for you guys before. It might not have been because I had the wrong focus on. So we'll just go back into that in a minute. Across this way, we're looking at a distance of 60.5 millimeters. Now, the width of the bit complete here, end to end, when I really squeeze it, because it's steel, so it's gonna be, hardened steel, 6.25. So we have 6.25 on the actual width of the bit. Now the hole, I would imagine the hole is gonna be oversized a touch, so let's take that measurement. Let's get a few of these bits out of here so we have some more space. Okay, let's check it now. Okay, so 6.78. So if the bit is 625, the bit is 6.25, the opening is around 6.65. I'm gonna take it again. 6.81, so let's say 6.75. I think 6.75 will be wide enough for this application. Now, for the actual holder on the bottom here that holds this piece, I'm gonna do that separately. I'm gonna add it to this, but I'm gonna do it separately, and I'll show you how I'm gonna do it. So let's sketch this whole thing out here. Let's double check our measurements of the width. We're gonna go with, let's go with 98 mil. Let's go with 98 mil wide by how much deep? Well, let's go how much deep by the actual sockets themselves. That's gonna be 40, so 40 millimeters. Now, we'll just put a few holes here just so you guys can get the general idea of what this is gonna look like. Okay, so we're looking at 40 up and down, 98 wide, and this is where our bit's gonna be. So now I've got to figure out the calculation of how I want these bits stacked within this space. So let's go ahead and do those numbers, and we will get into Fusion and get started. First things first, let's get our center rectangle. We're gonna create a sketch, and we're gonna hit S and start typing in center. And for some reason, it's not giving it to me. Maybe this new update, create sketch, there we go. S, center, beautiful, it is working. All right, so our measurements are 98 by 40. Heck, let's just go to 100. Let's do it at 100. Let's just make things nice and even. Okay, finish sketch. Now, when I hit finish sketch, I think you can actually extrude it before you click finish. I like to hit finish, it's just cleaner for me. We're gonna extrude this up 20 mil. Now, we need to sketch on our face here. So, to do this is gonna be a little tricky, mainly from my lack of experience, but we'll do it together. So we have 27 bits, which means we have 9 across. So 1, 2, 3, 4, 5, 6, 7, 8, 9 times 3 is 27. Okay, so let us do this. Let's start with our initial measurement of 6.725. So let's start this one in the middle. Let's go 6.725. 6.75, excuse me. 6.75, enter, and we're going to hit our construction line, so this goes perpendicular, up and down. Okay, now this is saying 6 points. See, this is where it gets tricky here. This is where I've made tons of mistakes when it came to my, little handle here that I did. I was measuring, what I was doing was, I was taking the measurement and it was doing this, right? It was saying 6.725 on one side of the center. So in actuality, that's over 13.5, right? That's probably 13.5. So let us take this from 6.75, and I think what I will do is just make it an even 7. Let's try an even 7. So half of 7 would be, now I forget how to edit this, so let's just Command Z it, and we'll do it again. And now, simple math tells us, and we'll do it together anyways, because sometimes math may not be so simple to everybody, and I'm one of those people. So let's go. 7 divided by 2 is going to give us 3.5. So our edge here needs to be 3.5, because now that's giving us a full 7 mil across. We're going to hit our construction line, so it's good. Then we're going to go back to line, and we're going to do this how we were doing our hex pattern, and this is the one thing that I've been learning. Not the greatest at it, so if it doesn't work, we'll get it. It's what I'm saying. It happens. That's the beauty of this thing. You live and you learn it, and you keep going. Okay, so I've got my construction lines. I'm going to try to pattern this out to save me the headache of trying to line all of these things up manually. So let us hit this, and let's see if we can actually get a rectangular pattern with it. There's numerous ways of why this always chops me up. You see how it's doing that? So watch. Let us take this. From what I see, it doesn't matter which way you add the construction lines, meaning top or bottom. It's just a matter of which way the pattern is going to go. And that's what it equals out to. See, the problem is it's doing this again. This is what catches me up all the time on why it's doing this. Okay, we've got our hexagonal pattern in. Now we have to set the depth. So according to this box here, we've got about, I'd say it's going just over the shoulder of the bit. So it's coming right over the shoulder of the bit. So give or take 12.75. So let's call it a cool 12. Let's just give it a 12 and we'll go from there. So let's drop, actually, excuse me, I was measuring from the top. We're gonna go from just over the shoulder. That's 12.15, so it's the same. It's gonna be 12. So let's hit these. 1, 2, 3, 4, 5, 6, and 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Let's extrude these down -12. Boom. Okay, so we've got our pattern. We've got our general shape here. Now, I'm not worried about the edges. I'm gonna mess with all that after. We'll get creative with that after. The idea now is to have some sort of French cleat design on the back. What I'm thinking, and I'm not the most proficient with French cleats. For right now, let's just test print this fit. Let's see how this fit is, and we'll take it from there. I'm just gonna go with it as is. Let's give it some little rounder edges. And I finally figured out how to rotate like this. You hold your center button on your mouse, or I'm not really sure how to do it on just a trackpad. With the mouse, you hold the center button, hold shift, and you use your scroll wheel left and right, or you move your mouse. That gives you your rotation, and then to move it, you hold down on the center button. It's nice to have these little hacks because you get more proficient as you go. Let's give this a nice fillet, and let's see what 2 looks like. 2 might be just right. Yeah, 2's looking good to me. Let's hit OK. All right, now, we still need the attachment for the actual wrench itself. That is going to be the same, well, yeah, probably around the same 12 mil. And the width of the tool is 89.57, so we'll call it 90. And the length is 90 and the width is about 14.5. So 14.5. All right, let's print this. Let's send this off to the printer and see what we get. All right, awesome. We're heading over to the printer now. As you can see on the screen here, I made some modifications. The first version, I just did the actual shape and the bits themselves, meaning just this shelf. The next version, I moved it down, and you can see here on the screen, I actually added a space. So in this original design, they stack both the extension bit here as well as the mini wrench right on top of each other. But what I did here was I separated the two, so now you have the room to grab one or the other at any time you want. So you can see here, and what I also did was I wound up putting in these little shelves, very similar to the little shelf that's inside of this bit holder. This one snaps in place right here. I made that side the width of this, and I made the other side the width of this. So it's gonna accommodate for the different shape. And then for this one, I just did an 8mm, kind of like an 8mm tower, or the tower was as wide as the body. And then I cut out 8mm, dropped it down 6 on the extrusion, and that will hold this wrench. Hopefully I have the position in the right position. If not, we'll adjust it on the second version or whatever, the third or fourth version. But this is what we got so far. This is pretty cool. The next step to this is to add some sort of French cleat on the bottom so it can clip right onto the wall, and then I can remove it from the wall when I want to use it down on the table here. All right, we have gone from this to this. Now, keep in mind, I'm running out of filament, and that's why I have so many different colors here. I've got purple, I've got tan, and I've got a tiny bit of gray on the top. Regardless of that, everything is good on the bottom. The few things I'm gonna change on the version right now, which will be the updated version, hopefully the one that I end up posting in this video. Okay, the fit of the extension is perfect. You grab a little hold here, and it's super easy. The handle piece is perfect. The only problem is these sockets. So what happened was the original was 3.25, then I went up to 3.5, and I just posted a short showing that it was fitting perfectly. Unfortunately, maybe from my, again, lack of experience, but all the measurements are the same across the board and they all fit the same. So I'm thinking that 7 mil, once it's, you know, there's zero tolerance. It's definitely apparent there's zero tolerance. So let me go back in, let me adjust these to 8. I'll bring them up to 8. What I'm gonna also do on the face here, let me just remove these two so they don't fall. What I'll do on the face here, I will end up putting either a scallop on this side to make it easier to grab and a scallop here. So when you just, you know, pinch with your fingers, expand these to 8 mil, and I'm also gonna make my French cleat system. So what I'm gonna end up doing is have this out on an angle like this. So these things will sit in there and there won't be any cause for them to flap out. See, if it's on an angle like this, if it's straight up and down, this is gonna fall. If I go just a little bit, I'm good to go. So I'll design the back of this with a wedge, you know, and angle it this way, cut it across, and then I'll design the French cleat afterwards. For right now, let's just get it to sit like this, and let's get these to 8 mil so it's actually bigger. Apologize if I was looking at the screen, it just helps me see what I'm showing on the screen here. So let me dial this in and we'll be back with the final revised version. All right, awesome. This is the final design right here. Hopefully it's focusing on it. And I'll get some B-roll shots for you guys so you can actually see it by itself and with the pieces. First version, I stopped mid-print because I went to test fit and I could barely get the socket in, right? Then I went ahead and I remodeled it, and I showed you guys this one. Issue that we're gonna solve on the version 2 will be the angle so this can sit in a French cleat on the wall but also come down into one of those Gridfinity systems, which will be really unique. It'll be good to have both options. Then this is the final version. Everything fits. I put a little cut here so you can lift and grab your tool. This one fits in excellent. This one fits in perfect. And when I have that angle feature on this, it's going to be that much better to the point where it won't accidentally fall out like that. When it's on the angle, that's not going to happen. So it's going to be a nice angle, and then with the socket itself, the socket drops right in. So as you can see here in the beauty shots that I've laid out, the ease of use to grab the socket in and out, to be able to grab the ratchet, to be able to grab the extension. This is really unique. It's very, very custom because you can do it any way you want. If you want to make it long, meaning if you want to have it this long and have your tools on the right side, so it's shorter, slimmer profile in your draw, you can do that. The possibilities are endless. So once again, this is yet another video showing how you can literally print your way into anything you want. This is a unique skill to have, but it's also a skill that pays bills. So there's many facets to why people get into 3D modeling and 3D design in CAD design, and I'm starting to see that every time I use it, which is cool. I had no clue about this stuff. I knew it existed, but I knew very, very little about it. except the things you learn in a documentary, and that's about it. So if you guys have any suggestions on how I can make this better, throw it in the comments. I'd love to hear it. Also, I'm really pushing to grow this community because it seems that I'm getting a lot of traction. You guys are enjoying the shorts that I'm posting every day, as well as these long form videos. All of the comments, you guys are awesome. Thank you so much. Everybody who's been very supportive so far, you guys rock and roll. I'm gonna continue to pump out videos. If you guys have any suggestions, throw them in the comments. I'd love to hear it. And if I don't see you over the next couple of days, you'll see me on shorts, but we have the holidays coming up. Plan another long form in about 5 to 6 days. Until the next one, hit the like button, hit the subscribe button, share these videos with your buddies, especially your buddies that are doing 3D printing and modeling, and I'll see you in the next video. Thank you so much for tuning in.